Hi, I'm Hannah Newton. I'm a project manager here for the Science and Technology Facilities Council at Daresbury Laboratory, and I'm managing our involvement in the Deep Underground Neutrino Experiment, or DUNE. In that experiment, we're making anode plane assemblies, which are detectors that will ultimately go into the big DUNE experiment over in the FAR detector, which is in South Dakota, USA. So here we've got two sites of activity at the moment for the DUNE project. One is up in the tower building behind me, and there we're building the first APA for Proto-DUNE 2. So this is an experiment over CERN that will feed into the main DUNE experiment. We've got a second location just out of sight in the inner hall, and there we're really gearing up for DUNE. We're building a factory bespoke for this project that will be producing 150 of these APAs over the next few years. Daresbury itself has been established on this site for 50 years now and is a world leader in scientific excellence, from nuclear physics all the way through to scientific computing and everything in between. And we've been involved in DUNE and its precursor projects, and look forward to showing you a bit more today. Here in the tower area, we're building the first APA for Proto-DUNE 2. The design is very similar to our first Proto-DUNE APA, but we have made some modifications based on learning from that first experiment. The APAs are still approximately 6 by 2 meters, and they comprise mesh panels which are then wrapped with 150 micron diameter beryllium copper wire. We wind this wire in 4 different planes over that frame, and this totals about 24 kilometers of wire per APA. The machines that we're building the APAs on are also very interesting. So these winding machines have had several upgrades, and one of them is that we've now got these rotating arms at the ends of the machine to enable us to wind the entire APA frame once it's installed on the machine, rather than having to remove it, twist it round and remount it again, which is how we were previously working. We've also got the winder head here that you can see, and this now actively controls the wire tension to ensure that we've got a consistent tension as we maneuver that winding head around the APA frame. All of these things make our production slicker. The factory here is just over 1,000 square meters and comprises a pre-assembly area for the preparation of the APA frames prior to winding. There's also space here for storage and offline assembly away from the winders. We then move through to the main factory area, which will have 4 winding machines. You can see 3 winding machines under construction at the moment, and the 4th is the one up at the tower currently being used for Proto-DUNE 2. There's a dedicated crane for each winding machine, and the winding machines have just had their survey to align them. This is important for the operation of the winding head around the APA frames. The control system for the winders are being commissioned. You can see the team here commissioning winder machine 1. And this comprises a key new safety aspect, which is a light curtain sensing system, which will prevent personnel getting close to an operating winding machine. Once an APA is completed on a winder, it will then go onto a process car and leave the factory. It's then lifted up into a separate shipping area, which is a renovated plant room, and here the APAs will get installed in their shipping frames prior to leaving the factory via an external platform. Once leaving the factory, the APAs will then journey over to South Dakota in the US, where they will be installed 1 kilometer underground in the FAR detector site.